In 1982, the Soviet spacecraft Venera 13 broke through the poisonous clouds of sulfuric acid and landed on the surface of the most unforgiving planet in the solar system, Venus. The pressure there is enough to crush a submarine. The heat melts lead, and the sky is shrouded in clouds saturated with acid. Yet, even in this hell, Venera 13 survived for a record 127 minutes, transmitting images and data until the extreme heat and unbearable pressure destroyed it. The probe was designed to withstand any earthly catastrophe, but Venus proved to be far more formidable than scientists had imagined. Now, imagine a human standing on the surface of this infernal world. How long would they last? And what would kill them first? Let's find out. If you were to instantly appear on the surface of Venus without any protection, you wouldn't even have the chance to see anything. Death would be almost immediate, and not because of the extreme temperature or the sulfuric acid in the atmosphere. The colossal pressure would kill you first. The atmospheric pressure on Venus is comparable to being submerged 3,000 feet underwater. This pressure would instantly crush your body. However, it's probably fair to say you'd prefer to be equipped with a spacesuit built using the same technology as the Venera 13 probe. In that case, welcome to Venus. The first thing you'd notice as you look around is a dense yellow-orange gloom surrounding you, due to the thick atmosphere filled with carbon dioxide and sulfuric acid clouds. Sunlight is heavily diffused, plunging the planet into a perpetual twilight. But that's hardly an issue. There's not much to see anyway. Just barren plains covered in volcanic rock, cracks, and stones. Your spacesuit is reinforced with durable titanium plates capable of withstanding 90 atmospheres of pressure. This adds considerable weight, and you'll feel it here, since Venus's gravity is only 10% lower than Earth's, so the difference is barely noticeable. The thermal protection of your suit must be as advanced as possible, and for good reason. Venus is the hottest planet in the solar system, with a surface temperature of 470 degrees Celsius. Worse still, the heat is inescapable, even on the dark side of the planet. This is due to the greenhouse effect. Sunlight warms the planet, and the dense atmosphere traps the heat, creating a truly hellish greenhouse. Just like Venera 13, your spacesuit is equipped with multi-layered thermal shielding, with an outer layer made of silicon carbide capable of withstanding up to 500 degrees Celsius. The internal cooling system operates by evaporating special liquids that absorb heat and divert it away from your body. You struggle but persevere with confidence and manage to move across the scorching, rocky landscape. It's so hot here that metals like tin, zinc, and lead exist only in molten form. Poisonous sulfuric acid relentlessly attacks your suit, but for now it holds up, thanks to its titanium plates, coated with chemically resistant materials like tantalum and gold, which protect against corrosion. All around you is carbon dioxide in a supercritical state. At 90 bars of pressure, it's no longer just a gas, but something between a gas and a liquid, a medium that would destroy all life in an instant. After a short time, your condition starts to deteriorate. The cooling system is the first to fail. No matter how advanced, it simply can't withstand such extreme temperatures. Your suit begins to rapidly overheat from the inside. With no place to hide, heat stroke sets in instantly. You lose consciousness, and within a minute, the internal temperature reaches critical levels, and you die. At the same time, the chemical protection of your suit begins to fail. Aggressive sulfuric acid and the crushing pressure start to break it down. Its structure heats up, cracks, and collapses under Venus's hellish conditions. You lasted a whole 20 minutes on this planet, an impressive feat considering it's the hottest world in the solar system. However, in a standard NASA spacesuit, you wouldn't have even survived a minute. But what about the other planets in the solar system? What kind of protection would you need to survive? and which planet is the most dangerous. Your next destination is the closest planet to the Sun, and also the smallest in the solar system, Mercury. But your fate will depend on which side you choose to land on, the dark side or the sunlit side. The main problem is that Mercury has no atmosphere, meaning heat distribution is extremely uneven. As a result, surface temperatures fluctuate more dramatically than on any other planet in the solar system, from minus 173 degrees Celsius at night to 427 degrees Celsius during the day. And yet, you dare to step onto the cold, dark surface. Your durable suit protects you from the freezing temperatures, but the first thing you'll feel is the icy chill of the ground beneath your feet. Without an atmosphere, there's no medium to transfer heat. The first thing you'll notice is how much the landscape resembles the Moon. The surface is covered in craters, cracks, and dust dominated by shades of grey, with darkness broken only by the faint light of distant stars. In your ultra-protective thermal and anti-radiation suit, you can take a short walk on Mercury's dark side. However, waiting for the sun to rise is a fatal mistake. When the sun does appear, you'll notice that it looks completely different to how it looks on Earth. Instead of the usual warm yellowish hue, it shines with a blinding white intensity. This is because Mercury lacks an atmosphere to soften its light. Moreover, the sun appears 3 times larger and much brighter than it does from Earth. The temperature rises rapidly, and without proper protection, your suit wouldn't be able to shield you from lethal radiation. Ultraviolet rays would cause burns within minutes if no shielding system were in place. Fortunately, your suit is radiation-proof. However, even the most advanced cooling systems won't be able to maintain a safe temperature for long. Under the blazing sun, the temperature inside your suit inevitably rises, approaching critical levels. There's nowhere to take cover, and waiting for nightfall is pointless. Once the sun has risen, darkness won't return for another 29 Earth days. Within minutes, solar radiation seeps into your suit's electronic systems, disabling nearly all vital functions. Soon after, your internal organs start receiving lethal doses of radiation and begin to fail. Even though your oxygen supply is intact, your cooling system has completely shut down. You quickly lose consciousness and collapse onto Mercury's burning surface. Here, you lasted only 15 minutes. Intense radiation and extreme temperatures left you with no chance of survival. But perhaps your next destination will be different. Maybe you'll not only get the chance to walk its surface, but even stay there for good. Your next stop is Mars. You've landed on the equator of this planet, not far from the site where NASA's Curiosity rover touched down. The landscape appears both familiar and alien, resembling Earth's desert regions, but with an unusual atmosphere. The sky has a pale orange hue, and the plains around you are scattered with rocks and boulders. You're fortunate to have arrived during a Martian summer day, when temperatures at the equator can reach a comfortable 20 degrees Celsius. For now, your suit's thermal protection system remains idle. However, it will soon become essential, as nighttime temperatures will plummet to minus 70 degrees Celsius. Despite your heavy suit, movement here will be relatively easy. Mars's gravity is 2.5 times weaker than Earth's, meaning you weigh 2.5 times less. The temperature may still be tolerable, but you must remain aware of radiation, which is over 20 times higher than on Earth. During solar flares, it rises even further, as Mars lacks a magnetic field and dense atmosphere to shield against radiation. Fortunately, your suit is reinforced with multiple layers of Kevlar and polyethylene to minimize these risks. You've now spent several hours on the red planet without encountering serious difficulties. It seems nothing is stopping you from settling in and constructing a small underground shelter. However, this is far from an ideal plan. The longer you remain on Mars, the more its low gravity and intense radiation will weaken your health. This dangerous combination will slowly degrade your circulatory system, increase the risk of cardiovascular disease, and even impair brain function. After 10 hours on Mars, your oxygen supply has been depleted. Successfully returning to your spacecraft, you leave the red planet behind, but your next destination is truly exhilarating. You're heading toward a gas giant, the largest planet in the solar system. Reaching Jupiter and surviving is an incredibly difficult task. As you approach the gas giant, you encounter extreme levels of radiation, higher than anywhere else in the solar system, except for the Sun. This is due to Jupiter's immense magnetic field, which extends 7 million kilometers towards the Sun and nearly reaches Saturn's orbit in the opposite direction. This field, 18,000 times stronger than Earth's, traps vast amounts of solar radiation within its magnetosphere. Only the thick titanium hull of your spacecraft can shield you from its effects. Let's assume you managed to reach your destination. Now, you must descend into Jupiter's atmosphere. Fortunately, thanks to NASA's Galileo probe, which plunged into Jupiter in 1995, you have some idea of what to expect. The Galileo probe descended 87 miles into Jupiter's atmosphere before it ceased functioning. Its descent lasted 58 minutes, a remarkable survival time under such extreme conditions. Now, you must attempt to replicate this feat. Your spacesuit is uniquely designed to withstand intense radiation. Like Galileo, its outer shell is made of titanium alloy, hermetically sealed with polyethylene and Kevlar to reflect radiation. To counteract immense pressure, the suit has a multi-layered shock-absorbing system that distributes force evenly. Finally, you make the jump toward Jupiter. The first thing you encounter is ammonia clouds, located 12 miles above the planet's theoretical surface. The temperature here is below -100 degrees Celsius. Though it's unimaginably cold, your suit is equipped with thermal insulation, and you quickly fall past this freezing layer. Within a minute, temperatures begin to rise, and atmospheric pressure approaches Earth's. You're almost at Jupiter's surface. But what awaits you next are catastrophic winds reaching 370 miles per hour, which hurl you into a massive vortex. Your suit holds, but your body cannot withstand the immense G-forces, and you do not survive. Even then, the winds and lightning strikes, some spanning over 600 miles, fail to destroy your suit, so it continues its descent. With every passing mile, temperature and pressure intensify. Within minutes, your lifeless spacesuit reaches the water cloud layer, where temperatures hover around 0 degrees Celsius. In another 2 minutes, you descend into a depth of 87 miles, where the temperature has risen to 150 degrees Celsius and the pressure is 24 bars. This is the same depth where Galileo stopped transmitting. You lasted only 3 minutes since entering Jupiter's atmosphere, far too little time to witness anything extraordinary. However, had you chosen one of Jupiter's most fascinating moons, Europa, your fate may have been different. This time, you stand firmly on solid ground. Beneath your feet lies a thick ice crust, 9 to 15 miles deep, concealing an ocean of liquid water. The temperature here is a staggering -150 degrees Celsius, almost as cold as Mercury's dark side. You find yourself on an endless frozen wasteland, about the size of Earth's moon. Its smooth surface scarred by countless cracks. There's no atmosphere, and the radiation from Jupiter is extreme. Your suit protects you, but not for long. Due to Europa's weak gravity, your weight is 7.5 times less than on Earth, allowing you to move effortlessly despite your heavy suit. In the distance, you spot a massive geyser, spewing water vapor 120 miles into space. The ice beneath your feet trembles, and you collapse. Not from an earthquake, but because radiation has disabled your oxygen supply. Your vision darkens, dizziness sets in, and you soon lose consciousness. The irony? Europa has plenty of oxygen. It generates about 26 pounds of oxygen per second as Jupiter's radiation splits water molecules on its surface, but you won't be able to breathe it. Soon, the radiation destroys your suit entirely. You survived 15 minutes on Europa, the same amount of time you endured on Mercury. Now, a different gas giant awaits you. Through the spaceship's window, you see a planet you instantly recognize by its magnificent rings. You're approaching Saturn. Just like Jupiter, landing on this planet is impossible. But curiosity takes over, and once again, you're ready to take the risk. Donning a massive spacesuit with reinforced radiation protection, you prepare to jump. Already, in the upper layers of the atmosphere, you're greeted by a familiar sight, an aurora. Similar to Earth's northern lights, it appears due to the interaction of the planet's magnetic field with charged particles. Surprisingly, your instruments are still functioning, and your descent continues. After some time, you enter the troposphere, the lower atmospheric layer of Saturn, stretching 150 miles. Here, the weather conditions showcase their full power. Hurricanes and winds reach speeds of 1,300 feet per second, many times stronger than Earth's most destructive storms. It is in this layer that the reason behind Saturn's yellow appearance from space becomes evident. The answer lies in dense clouds composed of ammonia crystals. Even the slightest breach in your suit in this toxic environment would be instantly fatal. Near Saturn's hypothetical surface, temperatures drop to -200 degrees Celsius. This extreme cold immediately coats your suit in ice, and your electronic devices begin to fail. It seems like the end, yet you're still conscious. Darkness surrounds you, since hardly any sunlight reaches this depth. Before long, the increasing pressure starts to deform your suit. With each passing moment, breathing becomes harder, until the crushing force finally destroys your protection. You perish. You manage to survive for 5 minutes while falling into Saturn, slightly longer than on Jupiter. But just like Europa, Saturn has a much more promising landing candidate, its moon Titan, the only satellite in the solar system with a dense atmosphere. Stepping onto its surface, the thought that you're no longer endlessly falling into a gas giant is comforting. It truly warms your soul, figuratively and literally, since Titan's temperature is a relatively mild -180 degrees Celsius. To ensure survival, your spacesuit is covered in highly reflective materials that effectively repel the cold. Inside, it's lined with silica aerogel, an excellent insulator that blocks extreme temperatures and maintains thermal stability. However, visibility here is poor due to an atmosphere rich in organic compounds, casting everything in a yellowish haze. This will prevent you from seeing Jupiter or other celestial bodies in the sky, but moving on Titan is relatively easy, since its gravity is about 1/7 of Earth's. Even in a heavy suit, you'll feel comfortable. The atmospheric pressure here is also manageable, about 1.5 times larger compared to Earth. After some time, you discover a small lake resembling those on Earth, but don't even think about touching it. Instead of water, it's a mixture of methane and ethane. What exists as gas on Earth is liquid here, due to the frigid temperatures. You've now been here for over an hour. The radiation levels on Titan are higher than on Earth, but your suit continues to shield you, allowing you to explore. However, soon you start to shiver as an extreme cold creeps into your body. Your suit's thermal protection is failing against Titan's -180 degrees Celsius temperature. Half an hour later, you lose consciousness and collapse onto the icy surface, succumbing to hypothermia. You survived here for 2.5 hours. We can all agree that it's much better than a few minutes of falling into Saturn's abyss. Titan turned out to be an extremely cold world. But how would you fare on the coldest planet in the solar system? To find out, we head to Uranus. Looking at the bluish-green planet, you realize another plunge into a gas giant awaits you. However, this experience is unlikely to be much different from the previous ones. The probability of dying here from winds reaching 560 miles per hour is extremely high. And if you somehow survive that, the temperature of -220 degrees Celsius will finish you off. No thermal protection can save you. At best, your fall will last 3 to 5 minutes before inevitable death. A more interesting option is to visit Uranus's moons. First on the list is Titania, the planet's largest satellite with a radius of just 490 miles, half the size of our moon. If you weigh 175 pounds on Earth, you'd weigh only about 4.5 pounds on Titania. With your suit, the total weight would be around 9 pounds. But if you choose to land on Miranda, Uranus's smallest moon with a radius of just 146 miles, be careful not to drift into space. Your total weight, including the suit, would be just over 2 pounds. After experiencing near weightlessness on this tiny moon, you decide to move on. Up next is a journey to the planet that only one spacecraft has ever visited, Voyager 2. At first glance, Neptune appears as a peaceful blue planet. Seemingly harmless, but in reality, it's a true nightmare. It harbors a deadly mix of factors: temperatures below -200 degrees Celsius, an atmosphere composed of hydrogen, helium, and methane, and the strongest winds in the solar system, reaching 1,300 miles per hour, 5 times the speed of sound. And in radiation, which, while weaker than on Saturn or Jupiter, is still enough to damage your suit and harm you. As soon as you enter the upper atmosphere, you find yourself in a lethal zone of radiation and violent storms. Your existence on Neptune is fleeting, just 2 minutes of freefall before you hit an area of intense radiation winds, leading to instant death, regardless of how advanced your suit is. But there's still one destination left: Pluto, the dwarf planet, and the final challenge in our planetary survival challenge. The diameter of this dwarf planet is just 1,480 miles, which is smaller than our moon, which measures 2,160 miles across. Yet, despite its small size and low mass, Pluto has a thin but present atmosphere, offering slight protection from radiation. However, the radiation here is still abundant. Stepping onto Pluto's surface, your first task is to turn on your flashlight. Darkness reigns here. Looking up, you spot the sun, now resembling a bright star, its light taking over 5 hours to reach this distant world. Gravity is similar to that of the moon, so your heavy suit won't be a problem. What you should worry about is the temperature plunging to -220 degrees Celsius. Exploring the surface, you observe a mix of ice and grey-brown rock. Pluto appears like a frozen desert with hills and valleys, reminiscent of Mercury's dark side. After just a few minutes, the extreme cold begins to degrade your suit, making it brittle. A sudden breach occurs, and you perish instantly. Your time on this icy planet lasted only 8 minutes, marking the end of your planetary survival challenge. Elon Musk is convinced that we won't survive as a species without colonizing other planets. Exploration of extraterrestrial worlds will allow us to survive a possible apocalypse and also give us access to vast natural resources. And the starting point should be Mars. The head of SpaceX believes that human beings will first set foot on Mars by 2029, and within a few years after that, the first Martian colonies would start popping up around the planet. And while the preparation for the upcoming mission is in full swing, Mars remains a tricky place. Take dust, for example. Because of the intensity of winds there, dust would constantly accumulate on solar panels, and this would put them out of operation. Tiny rocks that dot the planet's surface could be even more damaging. In 2022, NASA showed images of the Curiosity rover's tires being torn to shreds by Martian soil. In fact, Mars is quite hostile. It's very cold, and the average temperature on the surface is about -60 degrees Celsius. A person there would quickly turn into an ice cube without some kind of protection or spacesuit. The magnetic field on the planet is very weak, and the atmosphere is 100 times thinner than the Earth's, meaning no protection from cosmic radiation. In addition, there's nothing to breathe, because the atmosphere of Mars is a poisonous cocktail of carbon dioxide, nitrogen, and argon gases. But with the help of modern technology, all this can be fixed. Even gravity, which is almost 3 times less than that on Earth, won't bring much trouble, although it will be necessary to spend several hours a day on special exercise machines to stay in good shape. Elon Musk is already preparing people to land on the red planet, but the flight will be very long. The average distance between Earth and Mars is 225 million kilometers. If you were driving a car at the speed of 112 kilometers per hour, it would take you 223 years to get there. At its closest point, the distance between the planets is about 62 million kilometers, and roughly 400 million kilometers at the farthest point. The best time for space flights to Mars from Earth comes once every 2 years, when the two planets' orbits are the closest. This is when the most advanced Starship spacecraft would launch from Earth. Each ship will be attached to a reusable carrier rocket with 42 Raptor engines. The total height of the rocket is 122 meters, the largest ever built, even surpassing NASA's Saturn V lunar rocket. The booster rocket will accelerate the spacecraft to a speed of 8,650 kilometers per hour, then detach and return to Earth. The ship will deliver people to Mars in about 7 months. And after filling the tanks with fuel made on Mars, the ship can be launched back to Earth using its own engines. To supply rockets with fuel, a plant will be built on Mars to produce methane and liquid oxygen from water ice and atmospheric carbon dioxide. The spacecraft will carry 100 or even 200 people and 100 tons of cargo. The Starship flotilla will make about 1,000 voyages a year. According to Musk, at this rate, by 2050, a city with millions of citizens and a developed industry could appear on the red planet. The idea is to build a city under protective domes. The dwellings will be built by robots before people arrive, and the rest could be printed by settlers using 3D printers. NASA has already held a competition for the best Martian house in a special program called 3D Printed Habitat Challenge. First place went to the Mars Ice House project, which is a 4-story igloo, an Eskimo yurt adapted to the conditions of Mars. It has many apartments and public rooms connected by a spiral staircase. The rooms would have curved walls to create the illusion of more space. But whatever shape the houses on Mars take, Elon Musk believes that the most important thing is to make the settlement independent of suppliers from Earth. Food would be grown on hydroponic farms powered by solar energy. As for the Martian soil, it's still unclear whether Earth plants will take root there. Recently, the lunar soil has been tested in the same regard. If there are settlers on the moon, they'll need to at least partially provide themselves with food. To find out if this would work, scientists from NASA and the University of Florida sowed green crops in lunar regolith and volcanic ash and added a nutrient solution. Arabidopsis thaliana, a relative of cruciferous vegetables, sprouted perfectly in this mixture, and this raised the moon's ranking as a site for colonization. Still, our satellite is too small to become a second Earth. Scientists are considering all the planets in the solar system that could become a full-fledged replacement for our home, even Mercury. It's difficult to imagine that a new Earth would be a celestial body that rotates so close to the Sun. Our star heats Mercury's surface to an average of 179 degrees Celsius, and the daily maximum temperature gets even higher, up to 427 degrees Celsius. And it has no atmosphere to deflect solar radiation. A solution to this was proposed back in 2011. The MESSENGER probe spotted a ton of Swiss cheese-like features on the surface of Mercury, which could indicate underground lava tubes. Colonies built inside such tubes would be naturally protected from solar radiation and extreme temperatures. But the lack of gravity is still an issue. The absence of gravity deprives human muscles of their usual load, and they begin to atrophy quite fast. And our bones would suffer even more. In prolonged weightlessness, for example, bone mass first decreases, then due to lack of stress on bones, calcium starts to break down and releases into the bloodstream, increasing the chance of bone fracture. Because the blood pressure in the human brain is much lower than in our feet, if you take gravity away, it would stabilize equally all across the body. This could lead to bleeding in blood vessels, impaired vision, and a stroke. But in case we decide to relocate to Venus, we'll avoid such troubles. The planet's gravity is almost equal to Earth's. Venus has a dense atmosphere that could shelter colonists from radiation. In addition, there's a huge amount of carbon dioxide accumulated in the atmosphere of the planet, and oxygen can be extracted from it. But there's a problem. Behind Venus's thick veil lies a living hell. Large quantities of carbon dioxide in the atmosphere create an extreme greenhouse effect and raise the temperature to about 475 degrees Celsius. The atmospheric pressure on Venus is about the same as the pressure at a depth of 900 meters underwater on Earth. So even the most protected probes would only survive for a few hours there before being flattened by the gigantic atmospheric press. The planet's upper atmosphere is also flooded with poisonous acid rain, many times more corrosive than the most acidic rain on our planet. And the wind, at a speed of 360 kilometers per hour, blows away everything in its path. So why do scientists still consider colonizing such a horrible planet? It turns out that Venus hides a place like Earth. At an altitude of about 50 kilometers, there's a region with a level of pressure and gravity almost like that found on Earth. And the temperature there is about 30 to 50 degrees Celsius. So building floating habitats behind the planet's clouds might be a good idea. The NASA team has already begun developing the high-altitude Venus operational concept. The initial mission envisaged an airship 129 meters long and 34 meters high, and protected from high temperatures with only a thin outer layer. One idea was to use a nitrogen and oxygen mixture as a lifting gas for the airship, making its full volume habitable. It would make the airship lighter than the Venusian atmosphere, allowing it to float above the clouds. And because Venus is close to the Sun, there would be abundant solar energy, meaning no problems with energy to power floating habitats and cool the airship. But at the edge of the solar system is yet another great place for colonists. Although this celestial body is Saturn's satellite, Titan is the size of a small planet and is the 10th largest object in the solar system, including the Sun. Its diameter is 1.06 times that of Mercury, 1.48 times that of the Moon, and 0.4 times that of Earth. The giant satellite resembles our planet more than any other celestial body in the solar system. Titan has many lakes of liquid methane and ethane, which are strikingly similar to Earth's bodies of water. They're constantly replenished by methane rains. The land is covered with dunes of solid hydrocarbons that look similar to the sand dunes on Earth. These hydrocarbons could be an excellent source of energy for the colonists. Even there, on this distant world, humans would have shields against radiation. Saturn's magnetosphere and Titan's nitrogen atmosphere are 50% thicker than Earth's, and water ice just beneath the surface of the satellite can be used to produce oxygen. And Titan is terribly cold. Temperatures average about minus 180 degrees Celsius, but colonists don't have to hide from the bitter cold under a spacesuit. Titan's dense atmosphere dissipates the cold, which could allow people to walk around wearing warm clothes and respirators. And they could make housing out of plastic using local raw materials. Scientists believe that on Titan, we should build houses in the form of domes inflated with warm oxygen and nitrogen. Another unique feature about Titan is that the first people could fly like birds there. Weak gravity combined with a dense atmosphere would allow you to perform stunts in the air with wings attached to your back. But do we actually need another celestial body to live on? The idea of colonizing space isn't really new, as it was proposed back in 1975. But recently a team from Stanford University developed a project for a modern settlement among the stars and planets. It's made in the form of a torus with a diameter of 1.6 kilometers and a thickness of 150 meters. Such a dwelling would be able to accommodate 10,000 people. It would need to rotate continuously around the axis to create artificial gravity. There would be an industrial area for processing ore from nearby planets and their satellites. The leftover slag could be dumped outside, as it would become a reliable shield against all types of radiation. In the living area, each colonist would be given a separate apartment, located on different levels. All of them would be connected by spiral staircases, where people would often see each other upside down. The effect would occur as a result of the constant rotation of the structure. If you had the chance to spend one day on any planet without health risks, which one would you choose and why? Share your thoughts in the comments. And if you enjoyed this planetary survival challenge, support this video with a like and subscribe to our channel. Thanks for watching.